Okay, so here's where we are headed today. We're only going to spend one day on this section because 95% of this section is review from geometry. And once we go back over some things, I think it'll come back pretty quickly. We're going back to right triangle trigonometry. So here's what I mean by that when I say, here's what we're reviewing today. Okay? And we'll add a little bit of pre-calc to it, but here's what we're reviewing today. Back to SOHCAHTOA again. Okay? Setting up, solving sine, cosine, right triangle type problems. And again, just in case you need to write these down again, there's your reminder of what SOHCAHTOA stands for. The sine of an angle is the ratio of the opposite leg to the hypotenuse. Okay, that's your sine ratio. That's the SO part. Cosine of theta is adjacent leg, the ratio of adjacent leg to hypotenuse. That's the ka part of SOHCAHTOA. And the last portion, opposite leg over adjacent leg. Anytime you're using the two legs, you're dealing with a tangent problem. Okay? So just, this is going to be the main focus of today, going back and using this concept in right triangles completely. Not necessarily unit circle type stuff, okay? You're not necessarily going to be using the unit circle today. And we'll see if you remember. You remember back to geometry? Remember the toolkits that you used to fill out in geometry? All the different toolkits that you had? If you still have it, maybe you might have had, and the reason I say this is the toolkits that's the one right there. That's the one I'm talking about. If you still have it, one of the toolkits from geometry was everything triangle related. Talked about law of sines, law of cosines, sine, cosine, tangent, inverse trig. The reason I know that is because that is currently what I'm teaching in geometry. We're finishing that chapter right now. And it's probably, I've told them multiple times, it's probably the number one toolkit, main toolkit to hang on to, main toolkit to use. So if you have it someplace, if you still have geometry stuff somewhere, it'll help you. It'll help you at some point here. All right, let me give you example number one. Here's your first example. We're going to find the 6 trig ratios in relation to theta. So we're going to set up what is the sine of theta, what's the cosine of theta, and so on. So I put the first 3 trig ratios up. We'll get to the other 3 once we finish up with the first ones. First question I have for you. We'll see if you remember this off the top of your head or not. If not, we'll go through it anyway, just to confirm. Anybody tell me in order to do the sine, cosine, and tangent ratios, I'm going to need all 3 sides in order to set up those ratios. And I'm missing one right now. Anybody remember what the missing side is? 12. It is 12. It's one of your Pythagorean, if you remember back to Pythagorean triples, like a 3, 4, 5 triangle. This is a 5, 12, 13 triangle. Okay? Now, let's say you didn't remember that, because it has been a while. It's been 2 years since you've dealt with geometry and Pythagorean triples and all that. If you don't remember, you can call this side length x. Okay? And we'll do a quick review of Pythagorean theorem. Remember, Pythagorean theorem says leg squared plus leg squared equal to hypotenuse squared. So 5 and x are the 2 legs. So x squared plus 5 squared equal to your hypotenuse squared, which is 13. Like I said, if you didn't remember that off the top of your head, and not all the problems, by the way, will be Pythagorean triples, therefore you do need to know and remember the Pythagorean theorem. Now we square everything out. So we've got x squared plus 25 equal to 169. And now we solve. Subtract the 25 over. We get x squared equal to 144. And Take the square root of both sides, and the square root of 144 is 12. Okay? So if you didn't remember a 5, 12, 13 Pythagorean triple, here's what you would have done otherwise. Okay? Just set up your Pythagorean theorem and find your missing side length. And therefore, now that I have all three sides, now we can just use those sides to answer the question. Okay? For example, what is sine? Ratio of what to what? What over what? Opposite over hypotenuse. Okay? Which means in this problem, which two numbers? What over what? Yep. 5 is the leg opposite theta. 13 is the hypotenuse. And remember, when you're doing opposite versus adjacent, it depends on the angle you're using. We'll talk about that again. But opposite and adjacent completely depend on which angle you're referring to. Okay? So in this case, your sine would be 5 over 13. What's the cosine of theta? What is it, Haley? Yep. It's the ratio of adjacent to hypotenuse. Adjacent leg is 12. Hypotenuse is 13, so there's that one. And finally, tangent is your ratio of opposite to adjacent, which means, what is it in this problem? Opposite leg is 5, adjacent leg is 12, 5 over 12. Okay. There's your original 3 ratios. We said we wanted to find all 6, so let's add that back in then. See what you remember. Reciprocal of sine, which one is it? Secant or cosecant? Cosecant, opposite letter. Cosecant of theta is your reciprocal then. Now all you have to do is just take the reciprocal. 13/5. Cosine. Secant is the reciprocal, and therefore 13/12. And finally, cotangent is your reciprocal of tangent, which is 12/5. All right, let me stop just for a second because this was right here was a pretty quick review of geometry. Any questions, anything not make sense? We're using our ratios, we're setting things up, a little bit of Pythagorean theorem. All right, let's go into another one then. This one's a little bit more pre-calc version because you don't have a picture. You didn't deal with cosecant back in geometry, but still kind of the same idea. Given that the cosecant of theta is 17/4, I want to find the tangent. I want to know what's the tangent of theta. This problem is basically a reverse of the last problem, where you were given a picture and asked to find the ratios. Here you're given a ratio, so let's use it to draw a picture. And then we can go from there, okay? So if I draw a picture of this one, some right triangle, let's call that angle theta. How does knowing that the cosecant of theta is 17/4, how does that help me with my picture? Okay? It's the reciprocal of sine. So sine is normally opposite over hypotenuse, which means cosecant is hypotenuse over opposite. That tells me that 17 is my hypotenuse, and the opposite leg is 4. That's how the cosecant will help me. Okay? They give you some information, and then you work from there. Now, in order to find the tangent of theta, in order to find our tangent, we said the tangent is when you work with the two legs. Means I need to find the other leg. What do? Pythagorean theorem. Anytime you've got a right triangle and you know two sides, set up a Pythagorean theorem to find the third one. This one's not as nice. This one's not a Pythagorean triple. You can't necessarily just do this one in your head, so you actually have to work your way through this one. So x squared plus 4 squared equal to your hypotenuse squared. Okay, just keep in mind it's the two legs are together, and then the hypotenuse is by itself. All right, squared out, we get x squared plus 16 equal to 289, correct? 17 squared, 289? Okay. Subtract the 16 over. And what do we get? 273. And now we take the square root of both sides. This one's not as nice, not even close, okay? We end up with the square root of 273. I don't want you to go to the decimal. I want you to leave it as a square root because we're working on, when we deal with exact answers, like on the unit circle, we leave it with square root of 2 over 2 or square root of 3 over 2, things like that. We want to leave the square root in it. So that means x is is the square root of 273. Which means the tangent then is now what over what? 4 over the square root of 273. And as always, I'm going to always have you rationalize the denominator anytime there's a square root. How do I rationalize that? Just multiply by the radical. Multiply top and bottom by that square root. So we multiply by the square root of 273 on top and bottom. And we end up with 4 times the square root of 273 over 273. Can I reduce that at all? No. And therefore, not the nicest answer in the world, but it is the answer. Okay? But you do need to check to see if you can reduce any radicals, if you can reduce the fraction, any of that kind of stuff. But in this case, our tangent of theta is that. Okay? How we doing, okay? Getting there? Like I said, this was almost all stuff that you did back in geometry a couple years ago, just kind of refreshing. The cosecant, those types of things, like I said, those are new. Those are from last week. All right, now let's go to your unit circle. we're going to do one type of problem with the unit circle here. What's that?
I'm going to run to the bathroom.
Yeah. All right, so if you notice in this example, I'm asking you to find the exact value of theta, both in degrees and radians, of each one of these different problems. Cosine of theta, tangent of theta, we'll talk about that in a second. Notice, by the way, I did give you a quadrant to look in. Okay? We're going to only look at the answers that are in the first quadrant. We're not going to worry about other answers, and I'll talk about that as we start doing it. It'll make some more sense. The other thing I want to point out is this. Anytime you see find an exact value, they mean don't use a calculator. Leave the square roots. If it's square root of 2 over 2, then put it down as square root of 2 over 2. Okay, that kind of stuff. Leave your answers in exact answers. Okay, so here's the first question I have for you. All this says is the cosine of what angle in the first quadrant is square root of 2 over 2? Cosine of what angle? 45 degrees. Okay, cosine of 45 is the square root of 2 over 2. 45 degrees, which is pi over 4 radians. That's all that's asking is which angle has a cosine of the square root of 2 over 2. So it's kind of like working in reverse. If we go back and you remember back to geometry, if you remember inverse trigonometry, cosine -1, sine -1, that's kind of what we're doing. We're working backwards to find the angles now. Everything you've done on the unit circle up until now was, what's the cosine of 45? What's the sine of 30? It's always you've been given the angle, and you've been coming up with these answers. Now you're kind of given the answers and working back to the angle. Okay. Some of them will be straightforward. Some of them are a little bit more difficult once we get into the last couple and we're dealing with cotangent stuff. How about the next one? Where in the first quadrant on the unit circle does the tangent equal 1? 45 degrees again. Okay? The tangent, remember, is sine over cosine. If the tangent's going to equal 1, that's where the sine and cosine have to be the same. which is 45 degrees. Okay. Or once again, pi over 4 radians. That's all that this problem says. Tangent of which angle is 1? Tangent of which angle is 1? This is why, by the way, I put you only in the first quadrant, so you can narrow it down to just look at those angles in that case. You don't have to worry about quadrants 2, 3, or 4. And as long as we're talking about that, by the way, what's the number one difference between quadrants 1, 2, 3, and 4? There's really one main difference. Signs, yeah. Positive or negative. Whether it's a positive x, positive y, negative y. That's really the main difference depending on the quadrant. In this case, when we're in the first quadrant, we know that both the x and the y are going to be, notice all of these are positive because we're in the first quadrant. Okay, so let's keep going. Tangent of theta, square root of 3. 60? And hopefully, when you're doing your unit circle, I told you to kind of write the tangents down as well. Okay, so hopefully you have those on your unit circle. It is 60 degrees, which is what, by the way, in terms of radians? Pi over 3 radians, yep. Okay, so a 60 degree angle has a tangent. Tangent of 60 is pi over 3. How about the next one? Cosine of theta is 1/2. What is it? Also 60 degrees again. If you look at your x-coordinates, which x-coordinate in the first quadrant is 1/2? The only x-coordinate is 60 at 60 degrees. Or once again, pi over 3 radians. All right, now it gets a little bit messier because of cotangent and secant and stuff a little bit. A little bit more work you got to do. You're not going to necessarily just find a value. You're going to kind of have to work through it a little bit. Square root of 3 over 3. What do you think? Which angle has a cotangent of the square root of 3 over 3? What do you think? What do you think, Triton? Even if I don't even care if you're right or wrong at this point. I just want to be able to work through it. So 30, let's take a look, okay? Here, by the way, here's your unit circle again, okay? So let's take a look. If we think it's 30 degrees, okay? Tangent, remember, is sine over cosine, which means cotangent is cosine over sine. It's the reciprocal. So if I think it's 30 degrees, that means I'm going to take the square root of 3 over 2 and divide it by 1/2. Okay? Cosine divided by sine. But remember, when we divide by a fraction, we multiply by its reciprocal. So rather than divide by 1/2, I'm going to multiply by 2 over 1. And now we get 2 square root of 3 over 2. The 2's cancel. The cotangent is the square root of 3. Is that what I wanted? Nope, unfortunately, so it's not 30 degrees. What do we think? What's your next best guess?
60.
Okay, let's try 60 degrees. Let's see what happens. $60 degrees. Again, cotangent is cosine divided by sine. So if I take 1/2, instead of dividing, I'm going to multiply by the reciprocal. 2 over the square root of 3. We end up with 2 over 2 square root of 3. The 2's cancel. So we're left with 1 over the square root of 3. And when I rationalize that denominator, what do we end up with? Square root of 3 over 3. Okay? So it turns out it is 60 degrees again. Okay? This is why I said these last couple get a little bit messier. You can't just look at the unit circle. You got to kind of work your way through it a little bit. So it turns out, if I rationalize that denominator, I would get square root of 3 over 3. And therefore, theta, once again, is 60 degrees, or pi over 3 radians. Try the last one on your own. See if you can figure out where's the secant of theta equal to square root of 2. Which value of theta is the square root of 2? Which angle would you take the secant of to get the square root of 2? You should have at least a little bit of a hint on this one, just based on the problem originally. Should give you an idea of where to start. Which angle is the secant square equal to square root of 2? What do you think? What'd you come up with?
45.
It is 45. Here's a quick heads up, by the way, if you're thinking about this on where to start, use what you started with. And here's what I mean by that. In the last cotangent one, we had like square root of 3 over whatever. The reason I bring that up is, take a look at the ones that have the square root of 3's in it. Pretty good chance on the cotangent one it had to either be 30 or 60, because those are the ones that have square roots of 3's already in them. This one's got a square root of 2 in it. Pretty good chance that it's 45 because it's already got the square root of 2 in it. Okay, so if you think about that a little bit of, oh yeah, the 30's and the 60's have the square root of 3's, and the pi over 4's, the 45's have the square root of 2's, it at least gives you a point to start and actually go through and check. So if we say we're looking for the secant equal to the square root of 2, that means the reciprocal of cosine. Okay? Well, if I take the reciprocal of cosine, that's 2 over the square root of 2. And now we rationalize the denominator. We get 2 square root of 2 over 2. And the 2's cancel out. There's your square root of 2. There's the 45. Okay? You take the reciprocal of whichever one, sine or cosine, and it turns out that this one is 45 degrees. Like I said, this is still unit circle practice. It's just kind of now you're practicing in reverse. You're given the answer and you're working back to which angle gives you the answer. Okay? So you're practicing in reverse a little bit. Okay. Let me go on to the other part of what you're going to see today, which is some application problems. And I have this on a sheet. These are just right triangle. These are like basic geometry application problems. These are not anything super complicated or anything. So let me give you the picture, or let me give you the worksheet, and we'll go through a couple of these together. Okay, take a look. We'll get to, so first off, in general, when you're solving right triangle trig type word problems, draw a picture if you don't have one, label it, put the information in the picture, and then figure out how you're going to go about solving it. Okay? We'll get to that. I've got a couple of examples we'll get into. One quick heads up. When they talk about angle of elevation, angle of depression, okay? Those two things. one quick heads up, an angle of elevation is wherever you're at up to something. Okay, so for example, if I was standing in front of a huge building and I looked up at the top of the building, the difference between looking straight ahead versus looking up would be my angle of elevation. Okay? That eyesight, that angle, if my eyes were pointed straight ahead compared to if my eyes looked up at the top, that difference of the angle is what's called your angle of elevation. Okay? The angle of depression is the exact opposite. If I was standing on top of a large building and looking down at something, that's the angle of depression. If I looked straight ahead compared to looking down at whatever, a car, a person, whatever it might be, that's the difference. Let me ask you a quick question. See what you remember about geometry. How does the angle of elevation and angle of depression compare to each other? They're the same because, what kind of angles are these? We've got, these lines are parallel.
Oh, what are they called? Opposite side angles.
Alternate
interior
angles. Those are alternate interior angles. You've got parallel lines. Remember back to corresponding angles, alternate interior. Okay? These two angles will be the same. Okay? So just a heads up. All right. Let's go through and work through some of these. Number one, you have a picture, so we don't have to worry about drawing one. But I asked you to find the angle of elevation if you are 400 feet away from a building that is 850 feet tall. Okay.
400 divided by 8 gives you.
Hang on. First question, and somebody already asked this. It was a good question. Should your calculator be in radian or degree mode right now?
Radian.
There's a very simple way to know this answer.
Radian. There's no degrees.
Look at the picture.
You need degrees. So you need degrees.
Doesn't that say x degrees?
Oh.
Therefore, degrees. Okay? The picture says x number of degrees, so your calculator should be in degree mode. Okay? Let's set this up. First question. Sine, cosine, or tangent problem based on that picture? Which one? This is a tangent problem because you're working with the opposite leg compared to the angle and the adjacent. That's the TOA part of SOHCAHTOA. Okay? So this is a tangent problem. Tangent of x equal to, by definition, the ratio of opposite to adjacent. So 850 over 400. There's your equation. Now, if you take a look, I need to get x by itself, which again, we'll see if you remember or not. I need to get x by itself. How do I get rid of the tangent? What's the opposite of tangent? If you look on your calculator, it's not, that's reciprocal, it's not the inverse. Cotangent's not the inverse. There's those buttons you remember, sine -1, cosine to the -1. Those are your inverse trig buttons, okay? So the opposite of tangent is inverse tangent. Okay? And just like anything else, just like if I took the square root to cancel out something that was squared, the inverse tangent will cancel out the tangent, leaving you with x. And just like always, whenever you solve an equation, anything you do to one side, you got to make sure you do the same thing to the other. So I took the inverse tangent on the left, which means I also need to take the inverse tangent of the right. And now if you type that into the calculator, what do we get? What's my approximate angle measure?
64.79.
Okay, that sounds right. 64.79 degrees. Okay. 64.79 degrees. Number one, make sure you're in degree mode, not in radian mode. Because in the picture it says degrees. Okay. Quick question, just in general, or quick comment, I guess I should say. You will use inverse sine, inverse cosine, or inverse tangent only when you're solving for an angle measure. That's the only time you use inverse trig. Okay? When you're solving for angles, that's where those inverses come into play. Okay? So just a heads up, that's why we used it here. Okay. All right, let's go to number 2. Now we got to actually draw a picture and see what we have. Example number 2, from the top of a tower, the angle of depression to a stake on the ground is 60 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the foot of the tower? Okay. So, let's say there's our 80-foot tall tower. Here's the ground. So therefore, there's our right angle. Okay. Now it says the angle of depression is 60 degrees. Here again, as you draw this, an angle of depression, if you're standing right here, would be if you are looking straight ahead compared to, now you're looking down specifically at something. That angle that is created, this angle right here, that's the 60-degree angle that they're telling you when they say the angle of depression. It's if you were looking straight ahead compared to now looking down at something. So it's actually not in the triangle is what I'm getting at. Okay, that 60-degree angle is not in the triangle. Which part of the triangle am I trying to find? The other leg or the hypotenuse?
The leg. The leg.
How far is the stake from the foot of the tower?
Leg.
There's the foot of the tower. There's the stake right there. Okay? So you are finding the other leg. Okay? So now, quick question on this one before we even set this up. The problem I have, I can't use Pythagorean Theorem here because I don't have two side lengths. But right now, I can't necessarily even use trigonometry either because I don't have one of the two acute angles in the triangle. So, we have two options. One option is, if that's 60, that means this has to be 30 for a total of 90 degrees. Or, like we had said earlier, the angle of depression and the angle of elevation will always be the same. So this has to be also 60 degrees. Okay? Now, it does not matter. It does not matter which one of those angles you pick. You can pick either one. We'll talk about the difference. Which one you want to pick, the 30 or the 60?
30.
Let's go with 30 for a specific reason, and then because the next one will cover if you'd have picked the 60. All right, sine, cosine, or tangent problem. And that's the angle I'm going to use. What do you think? Based on what we're using, somebody said it. We're working with the two legs again. Opposite and adjacent are the two pieces that we're working with. So this is, again, a tangent problem. Tangent of 30 degrees. I'm going to put it over 1, and you'll see why in a second. Equal to, by definition, the tangent ratio is opposite leg over adjacent leg. So in this case, x over 80. Okay? Leg opposite over leg adjacent. Now, quick question. Two quick questions. Number one, what if I would have picked the 60-degree angle? What would have changed in that equation? Yeah. If you picked 60 as your angle that you were using, then 80 becomes the opposite leg, and x becomes the adjacent. This would have flipped. Okay? So just keep that in mind when you're determining opposite versus adjacent. It always is in relation to the angle you're working with. Okay? Second question, is this problem in radians or degrees?
Degrees.
Yep, right here, we got a 60-degree angle in the problem, so you know you're in degrees. And now, here's how we solve it. Here's why I put this over 1. You've got a proportion. By putting it over 1, all I have to do is cross multiply. X times 1 gives me x. 80 times the tangent of 30 is the other diagonal. And now x is already by itself, so type it into the calculator. What do you get? What is 80 times the tangent of 30? 46 point what?
19.
Okay. Agree, by the way? Confirm? Yep. 46.19. And what was this? Feet. So based off of our calculations, that stake is about a little more than 46 feet away from the base of the tower. All right, here's what I want you to do. Try the third one on your own. I'm going to give you a few minutes. Read the problem, set up the picture, and see if you can go through and solve it. Be careful when you're putting the information into the picture. We'll give you a hint. If you do this correctly, your answer should end up being like 8 point something. Okay? So if you get 8 point, I don't remember exactly what it is, but it's 8 point something if you get the answer. If that's what you get, you got the answer right. If you need to check your picture, there's the picture up there.
So, you said 8.08?
All right, let's take a look, because it sounds like people are getting there or are close to getting there. First question, and like first thing in general, you got to make sure you set everything up correctly. So make sure you read the problem carefully as well. When it says a 30-degree angle with the ground, make sure you put the 30 degrees in the right spot. Okay, because if you accidentally put it up on the top, then there's the first mistake, and your answer is going to end up being thrown off. Once you've got the picture set up, now you got to determine sine, cosine, or tangent problem on this one. Which one do we work with? Based on the two parts we're working with. What is it? We're working with if I use the 30-degree angle, which I'm going to, you've got the adjacent leg and the hypotenuse. That's a cosine ratio. So we set it up as the cosine of 30. Again, I'm going to put it over 1. Equal to, by definition, adjacent over hypotenuse. Some people may have gotten stuck when you cross multiply. You get x times the cosine of 30 equal to 7. Is x by itself? It's not yet, right? How do I get x by itself? Don't overthink this one. If you're multiplying by something, you got to divide it out. Okay? In the problem, you're just doing the opposite of what's being done to the variable. So we're multiplying by the cosine of 30 in the problem, so we divide. And you should get an answer of approximately 8 point, what was it? 08? Okay. All right, here is your assignment for today. It's not a very long assignment.